So today we're going to take a look at boat electrical systems. We're going to have a look at some different charging sources, which are on the left of this picture here. So that could be the engine, it could be a boat's charger, it could be solar, things like that. In the middle, we're going to take a look at different battery setups and what you might find on your boat. And then we're going to have a look at some test equipment and some monitoring. I'm not going to go into a massive amount of troubleshooting on this, but this video is designed for beginners. So if you're new to boating, you've got some of these electrical systems on board and you want to try and find out a bit more information, this video is for you. So let's get started and take a look at a basic setup. Here we've got a simple engine and a battery. So when you start the engine, you use power from the battery, and when the engine is running, the engine's alternator charges the battery back up. So that could be fine for some smaller boats, but if you've got a larger boat and you've got a lot of electrical sources on board, things like a fridge, a TV and lights, what's going to happen is you're going to put a lot of pressure on that battery, and you could flatten that battery so much so that you're not able to start your engine. What you're going to find on most boats, and it doesn't really matter the quantity of the batteries at this stage, is that the batteries will be split into two banks. You'll have a dedicated group of batteries, it could be a single battery or more than one, to start the engines, and you'll have another set of batteries that is termed as house batteries, and these batteries are responsible for providing power to all the electrical items such as the TV, the navigation instruments, the fridge, the lights, etc. This then presents as a problem because we've got to charge these two separate battery banks, but we also need to maintain that idea of them being separate so that you don't flatten one or the other. So here you can see now that battery number 1 is linked to the engine and battery number 2 is linked to those house loads. So how exactly are we going to charge these now? So if we take a look at this next slide here, we can see different things. So on the left hand side we've got a battery switch, in the middle we've got some different relays, and on the right we've got something called a split charging diode. On the left you can see a battery 1, 2 and both switch. So you manually turn this to the different positions to either charge or discharge from that particular battery bank. So if it's set to 1, for example, that could be your engine batteries, and 2 could be your house, and then if you put it in the middle, you're going to draw energy and you're also going to charge both battery banks together. The middle two can either be activated by a button or they're activated by sensing the voltage that's coming in. So when they sense that something is actually charging, they automatically combine the batteries together to charge them up. The third one, which is a charging diode, works slightly differently, and we'll come on to that in a second, but essentially it does the same thing. It detects a voltage and then it starts charging the batteries. The first one is manual, and the second two different types, both the relays and the diode, are normally automated. So here we can see we've got the engine battery and the house battery, and we've got the 1, 2 and both switch. So when the engine starts, depending on where we've put that switch, we either charge the engine, the house bank, or we charge both at the same time. If we set that to both, the problem we've got is the discharged battery bank, which is probably the house bank, will actually start to take energy out of the engine starter battery. It's also manually operated, so you could potentially forget where you've put that or not switch it when the engine's running and not actually charge a house bank battery. The advantages of the 1, 2 and both switch are both its simplicity and its cost. If you've got something like this on board your boat, a voltage sensing relay, or just a standard relay that's activated from maybe the engine control panel, this removes the manual process of remembering to charge or to flick the battery from one to the other. When the engine alternator starts to deliver the power that's required to activate the charge relay, it automatically connects the two batteries together and then allows them both to be charged. The disadvantage of this system is that you can still get energy going from the charged battery to the depleted house bank battery, and you can see here that arrow showing that direction of travel. You might find on your boat that you've got a charge diode that looks something similar to what we've got here. The advantage of the charge diode is that it doesn't allow the battery that's got the most charge to charge the depleted battery bank. Power can only go one way through this. So it'll come in from the engine alternator and it will go out to the two different battery banks, but it can't go the other way. It can't go back through from engine to house, for example. The disadvantage of this is you get a bit of voltage drop. So you then have to try and compensate for that with either a smart alternator or a device that's going to boost the voltage very slightly, because what you normally find is that one of the battery banks doesn't actually receive the correct charging voltage, which is around 14.4 for a lead acid battery. You'll see that that voltage is slightly dropped, which means it's going to take longer to charge that battery and it might never reach full. Okay, so let's take a quick look at battery chargers. So when you're at the dock or the marina and you're plugged into the mains power, chances are you've got a battery charger on board, and that's now going to start to charge the battery so that you can use all the electronics on board the boat. You may have a single battery charger that has multiple outputs and is able to charge both battery banks, for example, the engine and house battery. You might have one battery charger and it just charges the house bank and the engine battery isn't charged at all at this stage. Or you might have two battery chargers and they individually charge the different battery banks. Now, there's no real way of sort of checking or testing this other than having a look at what you've got on your boat. Try and find the battery charger and try and work out where the wiring is going. The other way of doing this is putting the multimeter on the battery and turning the charger on, and that will tell you as the voltage starts to go up which battery is being charged, if it's one or both of them. And if you've got solar, the same probably applies. The solar probably charges the house bank. You can get some solar controllers that have two outputs, and again, all of these are split a bit like the battery chargers. They don't allow the batteries to be combined together and just try and charge both. They're normally two split, isolated outputs. Same for solar. You can get charge controllers that feature that kind of technology, and therefore you're able to charge the engine and the house battery. But normally speaking, you charge the house battery with the solar. Again, same sort of tests. If the sun's shining and you can see that there's a light on the charge controller, check the output of the battery with your multimeter and see what sort of voltage you're getting there, and that will tell you exactly where that charge is going. And then when it comes to batteries, chances are that your battery banks are set up something like this. You'll have one engine battery and a couple of house batteries. You might have just an engine and a single house battery, or you might have dual engine batteries and dual house bank batteries. There could be various reasons for this. It could be that you have more than one engine. It could be that there's a different voltage on one of these battery banks. But generally speaking, if you have a look at your batteries, you'll find one of these setups. If we take a quick look at different voltages of batteries, the batteries could be connected together. So you might find that you've actually got two 12-volt batteries connected in series to give you 24 volts, or you could find that your actual batteries are in parallel to give you more capacity and not to change the voltage. Again, you're going to have to just have a look at what the battery banks look like and how they're set up and do some tests with the multimeter to confirm that. But that then will give you the information that you need. In terms of battery chemistry, you could spend a whole hour talking about different battery chemistries, but what you normally find is that the same chemistry is in the same bank. As I say, that's not strictly true because some people are now combining lead acids with lithium, and there are various reasons that you can do that, but normally speaking, with your battery banks, you'll find that each bank is the same chemistry type. So your engine battery bank could be lead acid, and so could your house battery, or you might have one lithium and one standard lead acid, or they could be AGMs, something like that. But normally speaking, the chemistry of the battery banks are similar. And finally, test and monitoring. So one of the best things that you can buy is an inexpensive multimeter. You can pick these up on eBay, Amazon for around £5 or £6, and this is really going to tell you a lot of information. You're going to be able to work out a lot just by using this meter. So I would highly recommend you get one of those. You set it to voltage, and you just tap on the batteries. It's going to tell you what the battery voltage is. If you were to turn on the charger or run the engine, you're going to then understand what is charging what. And they're just really good for fault finding on board. So that's the first thing I would buy. You might also find that you've already got some voltmeters built into your boat. You might have an electrical panel that's got one on, and you can sometimes flip those between the different battery banks. Again, this is going to start telling you a bit more information. It's going to tell you roughly how charged your batteries are, but it doesn't really go into a lot of detail. The problem you have is when you're using your electrical equipment on board, that actually puts a load on the battery and pulls the voltage down. So it's very difficult to tell exactly how much power you've pulled out of the battery. What you need to do really is allow the battery to rest and then take the measurement, but still it's such a fine range of voltages that it doesn't give you the detail that you need. And as you can see with this example here, this voltmeter goes from 8 to 18 volts. Now really, you're not really interested in a lot of that range. You're not interested past about 15 volts, and you're certainly not interested below 12. For a lead acid battery, you need to start charging it when it's in around 12.4, 12.5 volts. And when it's fully charged, it's around 12.7 to 12.8 volts. So it's a really small range. The item on the right-hand side of the screen here, the Smart Shunt from Victron, that is really where you want to be. That unit is going to pull a lot of information out of the battery. It's going to count in amp hours how much power is pulled out and also how much power is put back into the battery. So you can start to see exactly how much runtime you've got left. You can start to see how much a particular item draws on the boat, and you can get a really good understanding of the state of charge of your batteries. So that's the order that I would sort of look at this if I was installing equipment on the boat. I would first of all start with an inexpensive multimeter. I would make sure that I've got a fixed voltage gauge on the boat somewhere, because again, it just shows that the alternator's working, and it's great for a quick glance at what the batteries are doing. And then finally, I would look to install a smart shunt. So finally, let's take a quick look at how my boat's set up. So we've got two battery banks. We've got a starter battery, and in the house bank, we've got two batteries in parallel. So we've got 280 amp hours of energy. That's not usable, but we won't go into that just at the moment, but that's what we've got. We've got a single charger at the top, as you can see here, and that charger is only connected to the house bank. If you follow the red wire, you can see it goes to the charging diode, and from what we've learned at the start of the presentation, you can't go that way through a charging diode. So the only way through the charging diode is from the engine. So that charger only charges the house bank. I've got a single switch that turns all the negatives off. So on the switch panel, and the engine itself is connected to this switch here. And when that's isolated, it cuts the negatives for all the supplies on the boat. And to this side, we've got a smart shunt. This is the Victron smart shunt that I was saying about. And this tells me the voltage of the starter battery through this wire here. It tells me the voltage of the house batteries through this wire, and it counts all of the amp hours and the electrical flow in amps that's coming out of the house bank. So that's how I monitor the house bank. You can see here that from that, it goes to the charger. So when the charger's putting power back in, it counts that. And when the electrical loads are being taken out through the switch panel here, through this line, it also records that information as well. So you can see here that the charger negative goes through the shunt, so we're counting the amps that go back in. And when we're taking power out of the battery through the switch panel, you can see that it's this side the shunt, so it also counts the amp hours and the amps that are coming out and going to the electrical loads on the boat. From the starter battery, you can see there's two wires. They're actually joined together for part of that journey, but after, one goes to the starter motor, and from the alternator, it goes through the charging diode. So although this battery starts the boat, it doesn't necessarily have to take the voltage back, but it does because it goes through the charge diode here. So out of the alternator comes a feed to the charge diode. One wire then comes back to the starter battery to charge that, and the other goes all the way through here through this fuse and into the house bank where it charges the house bank. There's actually no fuse on the starter side in our setup, only on the house bank side. The only thing that's missing from this diagram is that I've got a device that detects the voltage, as I said, because the charge diode actually drops a bit of voltage. It takes a measurement down here on these batteries and also here, and it compensates for that on the alternator. So it slightly boosts the incoming voltage so that when it reaches the house battery, it's at the right level to be charging that bank. The downside to that is it actually gives the starter battery a slightly hard time, and we can sometimes find 14.8 to 15 volts here on the starter battery. I'm actually having a problem with that which is the reason for the video. I thought it would be useful to actually go through some of this, but in the next video when we're back at the boat, I'm going to show you some of the troubleshooting tips. So I'm going to do an electrical systems 102 to go through some of this in practice, some of the tests that you can do, and also some of the troubleshooting steps that I'm going to go through to actually find out what's going on, because I've either got a problem with my alternator or I've got a problem with that device that's actually tricking the alternator into boosting the voltage a little bit. I hope that's been useful. I know it's a little bit of a death by PowerPoint, but I hope you've got some information from that. I hope it's been easy to follow. And if you've got any questions or any comments, please drop them in the comments box below and we'll get back to you. We'll see you next time.